Welcome back for another session of Functional Skills Maths. And today we're going to be focusing on ratio and proportion. Now, like always, before we get into the main part of the course today, we are going to start off with a starter activity wherein you have to scan the QR code or click on the link that your tutor will provide, answer the questions that are relating to all the previous sessions that we've covered so far. Let's see how well you've managed to retain all that information and what is your current status. Okay, so go ahead and get cracking on with that. Thank you. So hopefully these are the aims and objectives that we want to achieve by the end of the session, that you will be able to understand and problem solve and illustrate your knowledge of ratio and proportion. So question being, what is ratio? What do you know of ratio beforehand? So you might have come across this obviously when you were at school, in your previous education center. What exactly is ratio to you? What does it mean to you? Make a note of that quickly. And once you've made a note, let's have a look at the terminology we're going to go through in this session. So ratio is used to share things when we are being fair. It is also used when one thing has a greater representation than the other. So let's revisit some of the knowledge that we already have. And that's why I say it's back to basics. What is the ratio of purple counters to green? So how many purple counters do we have? 1, 2, 3, 4, 5, 6. How many green counters do we have? 1, 2. So when we write it down with as though it's 6 to 2. Now this colon there, I've actually pronounced it as 2. So it's 6 colon 2, I would say 6 to 2. And that's what we do in ratio and proportion. So let's continue with that. Can this be simplified? Yes, it can be simplified. We can simplify it further to what? We can simplify it further to 3 to 1. So when stating simplifying ratios, what do I mean by that? Well, ratios can be simplified by dividing each part by the common factors, the same as we did with fractions. So if whatever you divide by the top of a fraction, you divide by the bottom of a fraction. Likewise, we do the same thing, but this time it's on either side of the colon. So if we're dividing something on one side of the colon, we have to do the same thing on the other side. So example, we have 7 to 21. So 7 to 21, what can we divide 7 by and 21 by? Well, we can divide 7 by 7 and we can divide 21 by 7, which will give us what? It will give us 1 to 3. So how many 7 is going to 7? 1. How many 7 is going to 21? 3. So it can be simplified. 7 to 21 can be simplified to 1 to 3. Let's have a look at this question now. Ben, the painter, needs 6 liters of dark purple. He uses 4 liters of red paint and 2 liters of blue paint. So he wants to create 6 liters of dark purple. He uses 4 liters of red paint and 2 liters of blue paint. Let's look at the statement at the bottom. Write the ratio of the number of red tins to the number of blue tins in its simplest form. Well, we start off by saying how many red and how many blue there are. 4 red and 2 blue. But in its simplest form, we need to cancel on both sides. And when we do that, what happens? What number goes into 4 and 2? Well, 2 goes into 4 and 2. 4 divided by 2 is 2, and 2 divided by what you do on one side, you've got to do to the other. 2 divided by 2 is 1. So in the simplest form, it's 2 to 1 because you cannot simplify it any further. And that's what you have to do. That when you cannot go any further and you stop, that is the simplest form. Now, also remember that units are as important as is order. So when we have simplified 30 millimeters to 4 centimeters, notice that the first number has millimeters as units and the second number has centimeters as units. And these are different units. If you are trying to cancel and if you are trying to simplify, you need to make sure that you convert both sides to the same unit first. Okay, very important. Example, 30 millimeters and 4 centimeters would be converted to the same units of millimeters, which is 30 millimeters and 40 millimeters. Now it's very, very easy. When you have both units the same, it's very easy to carry on and continue simplifying. Also, another point is 2 to 5 is not the same as 5 to 2, because one quantity comes first and the other quantity comes second. They are relating to two different things. Very important to bear that in mind. So I want you all to note these things down, okay, as mentioned already before. Make sure they are both in the same units. Also, as an example, the ratio of 50p to £1 is not 50 to 1, it is 50 to 100, because what I've done is I've converted the £1 into pence. So because the first unit is pence, I've converted the second one also into pence. So now it's 50 to 100. And when you are simplifying that, you can simplify that all the way to 1 to 2. Okay, so let's have a look at certain examples where we are going to simplify certain ratios. Example number 1, simplify 25 to 30. So how do we do that? Well, first of all, write down the entire ratio, 25 to 30. Thereafter, ask yourself what number goes into 25 and 30 without any remainders. And if you're very good at your multiplications and divisions, you would know 5 goes into both. So then what you do is you divide one side by 5, and at the same time you divide the other side by 5. So 25 divided by 5 is 5, 30 divided by 5 is 6. Can you simplify any further? Is there a number that will go both into 5 and into 6 without any remainders? The answer is no. And because the answer is no, well, 5 to 6 is the simplified version of your answer, and it's in the simplest form. We can't make it any more simpler. Let's have a look at example number 2. Simplify 48 to 32. So once again, first step 1 is to write it down, 48 to 32. Step 2 is to identify what is the largest number that would go into 48 and 32. If you're good at your multiplication and division, you would know that it's the number 8. 8 goes into 48, 8 also goes into 32. What is 48 divided by 8? The answer is 6. And what's 32 divided by 8? The answer is 4. And is this the simplest form? You ask yourself that question. Is there a number that will go both into 6 and 4 without any remainders? And the obvious answer is yes. There is something that will go both into 6 and 4. And what is that? That is the number 2. So 2 will go into 6 and 2 will go into 4 as well. Therefore, what do? We continue simplifying it further. 6 divided by 2 is 3. 4 divided by 2 is 2. Now, let's ask ourselves, is there a number that will go both into 3 and 2 without any remainders? And the answer is no. So that is the simplest form. So going back and trying to simplify 48 to 32 in the simplest form is 3 to 2. Let's move on to the final example. Simplify 75p to £1.25. So what's the first thing we've got to do? First thing we've got to do is write it down, 75p to £1.25. But the second thing is that we've got to make sure that the units are the same. When we change the units before simplifying, that makes our life really, really easy. Otherwise, a lot of students can get confused and they'll just get the wrong answer as well. So it's best to always do it at this stage. So when we do it at this stage, we are converting £1.25 to 125 pence. Thereafter, we are finding out what is the largest number that goes both into 75 and 125, and the largest number is 25 itself. How many 25 is going to 75? 3. How many 25 is going to 125? 5. Now let's ask ourselves again the next question. Is there a number that will go both into 3 and 5 without any remainders? And the resounding answer is no. Therefore 3 to 5 is the answer in the most simplest form. So when you have two numbers, not a problem. But what do you do when you have 3 parts or 4 parts in a certain ratio? Like for example here, look at the top example here, 7 to 14 to 21. Or the example 3 to 12 to 24 to 36. Well, let's deal with the first one first. It's very easy, very simple. You follow the exact same rule. You try to identify the largest number that will fit into each of those numbers without any remainders. So what will go into 7, 14, and 21. 7. 7 is the highest common factor. And once you know that 7 is the highest common factor, what do? Well, you do the same thing. You find out what is 7 divided by 7 is 1, what is 14 divided by 7 is 2, what's 21 divided by 7 is 3. And then you ask yourself the question again, is there a number that will fit into 1, 2, and 3 without any remainders other than the number 1? And the answer is no. Therefore, that is the most simplest form. Let's go to the second example and ask ourselves the same question. What is the highest common factor that will fit into all of them? And the highest common factor is 3. 3 is the highest common factor that will fit into all those numbers. And when we simplify it, how many 3 is going to 3? 1. How many 3 is going to 12? 4. How many 3 is going to 24? 8. And how many 3 is going to 36? 12. Now we are left with this answer here, and then we ask ourselves, is there a number that will go into all of them without any remaining? Yeah, okay, do they all have what is the highest common factor from amongst them? Do they share something which is really common amongst them all? And the answer is no, unfortunately, because you have the number 1 in there. And because of that, this 1 to 4 to 8 to 12, that is the highest, that is the simplest form. So let's have a quick example of sharing a quantity fairly, a question regarding that. So here's a scenario. Friends Bill and Betty buy a £1 lottery ticket, the national lottery. Bill pays 60p and Betty the other 40p towards it. So collectively, that's what makes the £1. They win £1,000. Should they get £500 each now? That is the question. Now, if they both get £500 each, is that fair? Especially when Bill paid the greater share and Betty paid the lower share, the smaller share, the 40p. So how do we resolve this problem? They might be really good friends and they might decide to go halves. Rarely happens in real life as such. However, it would be more of a fair way to split the winnings in the same ratio as they paid. So how much would they get? That is the question. So let's have a look. So here we are. 60 to 40, that is the ratio, means that Bill will get 60 parts to Betty's 40. And between them, there are 100 parts. Now what do? We simplify the ratio. So when we simplify, what is the largest common factor between 60 and 40? It's 10. So 6 to 4 is the simplest format so far after dividing by 10. And thereafter, what we realize is that the number 2 goes both into 6 and 4, so we can simplify even further, and the simplest form is 3 to 2. Now, what do? We add the ratio together. 3 plus 2 is 5. Once we know that is the total of the ratios put together, the next thing that we do is we divide the amount by the total ratio. So what was the amount that they won? £1,000. So 1,000 divided by 5 is 200. So 200. Now that 200 is for each part. Each ratio is worth 200. So now put it back into the ratio for each person. Well, this is it. Bill gets 3, Betty gets 2. So 3 times 200 is 600. And for Betty, 2 times 200 is 400. So who will get what amount? Bill will get £600 and Betty will get £400 from their respective initial investment towards that £1 that they had. And of course, this seems to be more fair and more equitable. Have a look at this video. Click on the link and go through the entire video, and that will give you a good understanding of how to express ratio as a fraction. So continuing on with that, let's give ourselves a quick question. So the question is, in a Valentine's Day bouquet, the ratio of red to white roses is 3 to 1. What fraction are red roses? So what you do here is you look at the two different ratios, 3 to 1, you add them together. 3 to 1 is 4, and of the 4, you basically know that 3 will be red roses and 1 will be white, because that's the ratio. You know for a fact that 3 out of 4 is a fraction. And it's as simple as that. Another thing that you might be interested in knowing is that a ratio might be expressed as either a fraction or a percentage. So, for example, express the ratio 3 to 7 as a fraction and a percentage. Well, what do? We add the two different ratios that we have there in front of us. 3 plus 7 equals 10. So 10 parts in total. If 10 parts in total, then we know that as a fraction, the 3 is 3 over 10 and the 7 is 7 over 10. And so 3 over 10 to 7 over 10 is in fraction format. And if we were to present it as percentage, then it will be 30% to 70%. Now, what I want you to do is on your own, work through the questions in the workbook on the dividing ratio, the page number or the exact specific page your tutor will be able to tell you. Set A questions are the easiest, by the way, so you should always start off with that. And once you finish, go on to set B, slightly trickier. And finally, I want you all to try set C, which are questions say for when you have really mastered everything else and you know your stuff properly. So you should all answer set C questions also. So go ahead, get cracking on with that right now. So when we talk about ratio, it always comes along with another word, proportion. So what is proportion? Proportion is two ratios that have been set equal to each other. And a proportion is an equation that can be solved. So every time you change one aspect of the ratio and the proportion, you have to change the other aspect, and the two are always the same. They will always remain constant. Now, in order to explain that in a bit more detail, let's have a look at some examples. Given that 8 oranges cost 88p, how much would you expect to pay for 16 oranges? Well done. Okay, so if this is what you said, £1.76, well, yeah, you're right. 2 times 88 equals 176 pence. 176 is £1.76. You are buying twice as many. So this is what we call proportional. Another one, another method, 88 pence divided by 8 is 11 pence for the price of one orange. If you know the price of one orange, then you can find out the price of any amount of oranges. So you want to know how much you're going to be paying for 16 oranges? Well, you know the price of one is 11 pence. So just 16 times 11p is 176p, which is £1.76. So these are two different methods of trying to get to your answer. So calculating direct proportions. Now, there's something called direct proportion and inverse proportion. We're going to come back to inverse proportion later on. We're going to go through direct proportions right now. So have a look at this. In recipes, if you know the amount of an ingredient needed for 6 people but want to serve 3 people, you would simply half all the ingredients. Sometimes the proportions are not that obvious. So here's an example. You need 500 grams of mince for 4 people. How many grams are needed for 3? So once again, there are different methods of trying to arrive at the answer. One of the things that you could do is you can find the amount for one person and then multiply this by the amount needed. So if you know that for 500 grams is needed for 4 people, well, let's find out how much is for one person. So it's 500 divided by 4, and that will give you basically 125 grams. Now, if you know that one person is 125 grams, then all you need to do is multiply by 3 to get your final answer, and which is 125 times 3 is 375 grams for 3 people. Okay, now to move on further, what I want you all to do is go to Maths Watch, and then there's clip KS3, clip R8. I want you to go through this entire video, pause when required, answer those questions, and then continue all the way until the end. Once you've finished all of that, come back to this point here on your PowerPoint presentation and click on the next slide. Now that you've had a look at your video, I want you to try and answer this question now. How much of each ingredient would I need for 5 cakes? Each ingredient. Look at it, work it out, and then confirm with your tutor whether your answers are correct or not. So coming to a conclusion, to the end of our session today, Have you met your objectives today? Well, now you can understand the importance of ratio and proportion, convert ratio to its simplest form, use ratio and proportion to solve problems, convert ratio to fractions, conduct activities using proportion. Any further questions? If you have any further questions, ask your tutor right now. And other than that, what we're going to do, we're going to test yourselves to see if you have met the objectives today. And we'll do that by completing the end of the session plenary form activity, which is on Microsoft Forms. So let's see you answering all these questions and getting as many right as possible. So get your mobile phones out or the scanning devices or the link that your tutor is going to give you and take it from there.